Hey everyone, welcome back to the shop. Today we're going to be building Hero's jet engine. So I actually remembered to turn on the cameras today before I was done building something, so hopefully this video will be a bit more entertaining than me just rambling for 10 minutes. But I'm getting ahead of myself. Let's talk about what we're actually going to be doing today. So I'm going to be trying to build this thing called Hero's jet engine, which is essentially a primitive steam turbine made by Hero of Alexandria back in the year 50 AD, I believe. I'm pretty sure he was some Greek scientist or something of that matter. Basically what it is, and I've already started drawing it here, is a cylinder or a sphere or some sort of a shape, really. It's not exactly important, with a axle through the middle, and it can freely rotate on that axle. But what this axle does is it's actually a pipe which goes down to some sort of a source for steam down here. Steam goes up this pipe through these holes in the pipe here, fills up this chamber with steam, and there's two nozzles, or I suppose there could be more, on opposing sides of this cylinder with little holes in the end of them. And the steam can get out of these, go up through these nozzles, sprays out the end, and this whole thing rotates. So I guess it's what one would call sort of cool desk toy, or at least that's why I'm making it. So you apply a little heat to the bottom here, maybe like an alcohol lamp. There's water in the chamber, and then you have a nice little spinny physics demonstration. Yeah, I saw it in a book and I thought it'd be pretty cool to build. So let me show you what I've done already, because I did kind of forget to turn on the cameras from the very beginning, but I haven't gotten very far into it. So what I've done is I've begun the main chamber here is what I'm going to call it, and I've gone ahead, let me focus that, and I've made this thing out of aluminum. It's got two little bearings pressed into either side, and I've bored out the center of it on the lathe, so there's a nice little hollow chamber in there. So as you can see, I haven't done too much work on it. So the next step, or what I'm going to do next, is make these nozzles here you see in the drawing. And what I'm going to be doing that with is this brass rod that I have on hand. I think it'll be cool, the contrasting colors between the brass and the aluminum in the finished product, so I'm just going to be making it out of brass. So I've kind of already experimented with some primitive nozzle designs. Here's one I made earlier. It's real basic. All it is I'm drilling out the rod, so it's a pipe, and threading it so it can thread into the body here. The top part is what I'm still working on. I can't decide whether to actually make a 90-degree somehow, like solder on another piece, or I mean, I can't really bend this stuff in such a short length. But what I think I'm going to do is have something sort of like this, round off the end on the lathe with some sort of, I'll file it, make a nice decorative round end, and I think I'm just going to cross drill a little hole. So it'll just be a little round shape with a hole in the side of it. Nothing too fancy, but it doesn't need to be. And I'll make two of those. Those will thread in the side, and finally I have to work out the actual piping. That again is going to be made out of more of this brass rod. I'll just drill that out. These will be solder joints, I assume, and we'll figure out some sort of a boiler system. In fact, I'll probably just run it off of compressed air at first to see if it even works, but yeah. So I think right now we're gonna head over to the lathe and figure out how we're gonna do these nozzles. Alright, so we're all set up here over at the lathe. I've actually got my drill chuck in the spindle here, as you can see, because personally I find this a lot better for working with small parts such as the brass blanks that we're going to be using today, just because it's a lot actually, compared to my 3-jaw, it's got a little bit less run out, and it's just easier to work around, and I just find it better for holding small parts. So basically, I've got my blanks prepared here. I'm just gonna face off both ends, drill it with a 1/8 inch drill bit real fast, and then we'll cut the threads, maybe cut the threads before we drill, then take it over to the mill and drill the little cross hole for the actual nozzle. So yeah, let's do it. So these holes have to be drilled pretty precisely, just because, oh, sorry about that, just because it is a pretty close tolerance piece, because it needs to get, hole needs to get pretty close to the top, but obviously not break through. So what I'm gonna do is I've paused before I drill. I'm just going to get my calipers, take a measurement of this piece, and then I'll, using the graduations on the tailstock, I will make sure I do not break through the other side. So I'm getting just under 1 inch on this 0.962. So to be safe, I'll stop 1/8 under 1 inch. And that will give me a fair amount of clearance to make sure I don't actually break through this thing. Actually, on second thought, I'm cutting the threads before I drill, because seeing as it's a pretty high force operation, I don't want to risk tearing or marring the part after it's already been drilled. So I'm not going to go very deep with these threads, because they really don't need to be. I'm only going to go about the depth of the die itself. So I'm just using the tailstock to get it aligned and give it some pressure. And now we're good. So now that it's started, I think the easiest way is just going to be doing it by hand. I'm spinning the lathe using one of the pulleys in the back. And yes, I should be using cutting fluid. That's where the squeaking's from. Getting a little bit tough there. Going into backup, which is engage back gear. And that should be good. Ooh, that really does sound terrible. All right. That was a 1/4 24 thread, by the way. I've found it's a pretty good for my purposes. So now that that's cut, I will reset up the tailstock for drilling, and we will drill that 1/8 inch hole to allow the steam to pass through. And we'll be drilling that to a total depth of 7/8 of an inch. And there we go. So now we're gonna flip this around. I'll just round off the end with a little needle file. Move the tailstock out the way. And then we'll be good to make another one. So I've got both of the nozzles done, as you can see here. I've just hit them with a Scotch-Brite for now. I'll polish them up real nice later for the final assembly. As you can see, I've held off on drilling the cross holes for the nozzle just because I want to wait till these are all the way screwed into the body so I can make sure that the nozzle holes end up nice and perpendicular with the axis of rotation. But anyways, now that we've got these done, we have to drill the holes and tap them to accept these nozzles in the actual body of the engine. So, as I mentioned earlier, these are just plain old quarter 28 threads. They're not like pipe threads or any special kind of threads like that. So they're not self-sealing. So we run into the problem of how do we get a good seal, since this is a pressurized steam system. We need to figure out how to get a good seal with just these regular old American fine threads. So normally you have with any standard thread, you have a spiral leakage path that follows the thread up, and that's what allows normal threads to leak, and that's the reason that tapered pipe threads don't leak. So the way we're going to combat this, and I've done this before with pretty good success, is since the tap itself is tapered in the amount of thread that it actually cuts, we just don't go all the way through with the tap. So there'll still be a point near the bottom of the hole where the threads are just hardly developed at all. So what that'll cause is, as we screw it in, it'll be screwing in real nice, and then it'll get really tight at the bottom, and that's just because these threads will be bottoming out, just digging right into the metal. So there's no chance of any leakage because they're basically making their own threads. I mean, they're not actually cutting their own threads, but they're just jamming in there as tight as they can. And that's a pretty good way in a pinch to make a seal with no special taps or thread forms or anything like that. So I think now we're going to go over to the mill. First I'll lay out a couple holes 180 degrees apart. We'll drill them, we'll tap them, and then we'll screw these together and get ready to do the cross holes. Alright, so we're all set up on the mill now. I've already got the first hole scribed, punched, and spotted, and now we've got our pilot drill ready to go. So we're just going to drill that out real fast and give it a quick tap. And we're through. I'll give this a quick countersink and I'll tap it real fast. So I've got the first one done, as you can see here. I've got the nozzle piece threaded in already. Turned out pretty good. So now we gotta do the second one. And it's very important that these be perfectly in line and parallel, or else it's gonna not only perform poorly, but it's gonna look bad. It's really gonna stand out. So to make sure that these two holes are like perfectly parallel, after I punch it, how I'm going to set it up in the mill is, what I'll do is I'll keep this nozzle in here and I'll set it just like this. So what will happen is it'll be straight in this axis, this rotational axis, because it'll be sitting on this reference face here, which I know is good. And it'll be good in this axis here because this pin or this nozzle will be up against the fixed jaw of the vise and holding it perfectly in position. So that's going to give me the best possible results for parallelism. So let's do that. guys, I think that's gonna do it for this video. We've got both nozzle pieces threaded in, ready to go. Turned out pretty darn good. They're both in nice alignment. Spins great. I think in the next video, we're gonna be doing the piping, doing our first tests, and of course, drilling those pesky cross holes there. But besides that, I'm pretty pleased with this. Hope you guys liked it, and thanks for watching.